Hi all. So in this video we'll see about the experiment 10, which is implementation of k-means clustering for customer segmentation. So the objective of this experiment is to group the mall customers based on their annual income and spending score. This is known as customer segmentations. So let's now see how it's implemented, the program implementation. We'll start by importing the required libraries and loading the dataset. So this is the first main step. This dataset has customer details like gender, age, annual income, and spending score. Next, we explore the data to understand the column structure and types. And this is known as the ELPO method to find the number of optimal clusters. So how do we do this is we use the ELPO method to determine the optimal number of clusters. It's also known as WCSS, which means within cluster sum of squares, which helps us to measure how well the points fit in a cluster. So from the graph here, we find that 5 clusters give the best balance of accuracy and simplicity. So the graph here is here. See, it will go down, and at a point we know that this is the optimal cluster. So that's that. And after that, now we train so once we get the number of optimal clusters and plot it in a graph, we train with the number of clusters we got in the previous step. So we now we train the k-means model with 5 clusters and assign the cluster labels to the data set. So that's this step. We filter the data based on each cluster so we can visualize them using matplotlib. So that's it. Each group has given a separate color to differentiate from. So this is the data.head and info output, the ELPO method graph which we discussed earlier, and the grouping and assigning of that, the final visualization graph. So each cluster is shown in a different color. This helps us to clearly see different customer types. For example, low income high spenders or high income low spenders, like vice versa. So coming to this, like what's the practical use of this k-means clustering? It's nothing but it's used in customer segmentation, market based analysis, image segmentation, anomaly detection, and healthcare. So thank you.